Hey everyone, so we are continuing the deep dive around unique ID generator. So previous video I explained you about one of the implementation, that is UID v7. If you haven't gone through that one, the links are available in the description box and comment section as well. Go ahead and check that out. This video, as per the agenda, we are going to cover the Snowflake in this one implementation. So let me take you there. So projects and all that I have explained in the previous video, so go ahead and check that out. So for the Snowflake implementation, before we go into the code and see this in real time, let me show you the step by step, because this is quite complicated and we have to see each and every step in detail. So the algorithm I have explained in the system design video as well. So if you haven't watched that, go ahead and check that out. We are revisiting those things in here as well, and I have written this down. So this composed of 4 parts: time instamp, data center ID, worker ID, and sequence. And this is how the structure is. 1 bit is here for that unused, 41 bit is there, 10 bit data center ID plus worker ID, and 12 bit sequence number is there. Okay, so this is further explanation. 1 bit always set to 0. This is the 41 bit time instamp, milliseconds in a custom epoch. 10 bit data center ID plus worker ID, 5 bit data center, 5 bit worker ID, and 12 bit sequence incremented counter within the same millisecond. What are the detailed steps? So define the constants that are needed, initialize variables, generate the IDs, and this is how we have to do while implementing this in the code. So this is the below Snowflake ID generated. The code is available in this markdown file itself. You can go ahead and check this directly. So this is what we are doing. So we are initializing it. Okay, we are putting the max one around it, we are putting the shift operators in here, and just initializing all the things that is needed. And this is the generator, the constructor basically. So it had some validation around it, data center ID and worker ID. When proper arguments are not passed, if they are fine, proper values are assigned. So and then comes the actual picture that is generating the ID. Let me take you to the down. So where I have written this down: initialize variables, generate the ID, get the current time instamp, check for clock going backward. So if current time instamp is less than time instamp, this is not possible. So even if it is coming in some edge or race condition cases, so refusing to generate the ID. If this condition passes, like if the current time instamp is the same as time instamp, increment the sequence. We saw that. If the call is coming to get the next ID within the same millisecond, so the sequence number will be incremented, right? And if that sequence number comes down to 0, current time instamp will wait for till the next millisecond that is coming in. If this is not the case, like if they are equal, current this will happen. Otherwise, sequence will always remain to the 0. Update the last time instamp, because we have to keep track of this one. If this is fine, we all have to combine all these things: current time instamp minus epoch, left shift operator on the time instamp, data center ID, worker ID, and sequence, and all this combined with the OR operator. This is the example. Let's say current time instamp minus epoch is coming this one, shift left by 22 bits. This is the number that you will get it. Data center ID part, this operation will return this number. Worker ID, shift left by 12 bits, this number we will get it. Sequence part, that is going to be the 0 for each millisecond, and we will increment, combining all this number, this number, this is the ID that we will get as a Snowflake ID. So all this is implemented in Java only. Let me take you the project. Okay, so this is the unique ID controller, and this is the next one, not the sequential, but this is the REST endpoint for this one, Snowflake ID. If I come to this one, I will get this Snowflake ID generated dependency, and this will take me to this Snowflake ID, that same Java implementation that I just explained over there, right? Sequence, this one. Okay, so generating Snowflake ID, sequence number, sequence number, time till next millis, and this one, get worker ID and get data center ID. So these are the tricky things about data center ID and worker ID that I'll come in a bit. Okay, but let's see, because the project is already running in here, I will just put a debug point in here so that we can see this at runtime. Coming to this one, so I just have to mention Snowflake. Okay, so debugger has come, debugger is there in the generate Snowflake ID. So time instamp, so just come to debugger and see time instamp, we got this number. This compared time instamp less than last time instamp. This is the first call, obviously, like that is coming. So this is okay, this condition is not true, so it is not going to throw the runtime exception. We will get to this one time instamp, because this last time instamp with this time instamp is not equal, so the sequence number will be 0 again. Last time instamp, this will be updated, and we are done. So this is doing it in all one step, all the shift operators that are there, and we will get the ID. Okay, so this is how. Wait 1 minute. Snowflake ID, right? So we should be okay. Why am I getting this sequential code? Okay, so I think there is some, these lines of are edited, that is why this is not sync. So let me just restart this one, right? So just give me a minute. I will just restart this, because I added these lines in here, right? So that is why they are not in sync, the debugger and the line of source code. So let it restart once. Adding welcome template. So yeah, service started. Okay, so let me come here again and refresh this page. Okay, so the call has already come in here. So if I go one by one, so this is how I will get here, and this is how I got the generated ID. And this is just setting that Snowflake and saving that in the database, as I explained earlier, that this is making the entry in H2 database. So this is how if I pass it on, I will get the ID in here, ID and generated at this point in time. So if I come to this UI in here and coming to Snowflake, if I click this one, I will just remove the debugger from here, and I will get the ID in here, right? If I have to get the last 5 IDs, I will get the details in here, showing you the same thing in H2 console, basically, because system was restarted. This is the in-memory database. Just make sure when you restart, everything will be cleared. Generated ID, if I refresh, I got all the Snowflake IDs, right? And if I have to get the last 5 IDs, you can just compare it by doing the ordering by timestamp and see IDs are there or not. So just in the previous video that I showed, you can do that one. So if I generate the UID v7 also, I should be able to see that as well. So just run this. Snowflake UID v7, both are coming in here. So that, I think, concludes this video about the implementation of Snowflake and UID v7 generation. Only thing pending is the testing. Writing the test cases for highly concurrent environment, distributed system. We will do that thing and doing the load test around it. So let me plan that as well. I'll try to come up with that as soon as possible. In the meantime, make sure that you subscribe to the channel, share it with the friends, and check out other resources that are available on the channel, and all of these things that are available in this GitHub repository, so make sure that you check for this one. If you want to make any improvement in this code, whatever I'm pushing in, make sure that you check that out and you raise an MR by taking that code. I will be happy to review that one and have a discussion with you and make the changes in the main branch as well. So feel free to do that. So that's it about this one. I'll see you in the next one. Till then, take care. Bye bye.